All right, well, good morning, good afternoon, good evening, good morning, good afternoon. Whenever you're watching the videos, congratulations. We are now watching section 6.7, or I guess part B. We're going to do a couple more examples. We're going to, again, this section talks about solving equations using the zero product rule. And we're going to talk about a couple more examples. We did some examples before, so doing a couple more examples. So we're going to talk about what these are. So we're going to solve equations using the zero product rule. We went through the definition. Let's go through the definition real quick of the zero product rule. Or sorry, I guess first of all, quadratic equations. A quadratic equation. Quadratic means we've got an x squared term, and equation means we've got an equal sign. So anytime we've got something over here that includes an x squared as the highest term, highest degree term, highest power term, and an equal sign, then we can start using. Then we've got a quadratic equation. When we have a quadratic equation, we can use the zero product rule. What's the zero product rule? Right down here. If you haven't highlighted it, I'll tell you again that highlight it and maybe put it on your cheat sheet and study guide. If a times b equals 0, then either a equals 0 or b equals 0. So we've got a factor here and a factor here. And if they equal to 0, then either of these factors is equal to 0. One of them is equal to 0. And we did some examples right down here. A was equal to 0 or b was equal to 0. And we've got some mini equation to solve. And then again, if I ask you to solve the equation, solve this equation, you have to tell me what x is equal to. All right, so let's go through. We did some of these. Here's the steps, I guess, to go through. Write the equation. In other words, everything on the left side with the x squared term. Remember that a cannot be equal to 0, I suppose. That's kind of the one, small print, I guess, of the zero product rule that says a cannot be equal to 0, but essentially anything that's over here is equal to 0, then you factor out the left side and set it equal to 0. So write everything such that everything's on the left side, or write the equation such that everything is on the left side. We've got an equal sign equal to 0. Factor completely. We've done that a lot. And then apply the zero product rule. A is equal to 0 or b is equal to 0. And sometimes we'll find maybe that there's more than a and b, and we might get to that today. So here's where we left off. Let's see. If I've got this equation, it's let's see, number one, I guess, is it a quadratic? It's a quadratic equation because we've got a quadratic, a second term, or a second power in our variable, and an equals 0. So if we do have that, we can use the zero factor property, or zero product rule, to try to solve this. So again, these instructions say solve the quadratic equation. It's a quadratic equation. So I've got everything over here equal everything over here equals 0. So if it's equal to 0, we can start factoring. And what's the greatest common factor between 4x squared and 24x? Well, we can probably factor out, let's see, how about a 4 and an x? And that would be about it, because if we've got 4x squared, the only thing left is another x, and this doesn't have an x squared here. So factor out a 4x. 4x squared divided by 4x gives me just 1x. 4 divided by 4 is 1. X squared divided by x is 1, or x to the first power, or just x. Plus 24x divided by plus 4x gives me a plus. 24 divided by 4 is 6. X divided by x is 1, and that equals 0. So now that we've got it factored, everything's factored, and we can say, well, we've got essentially three different factors: 4 times x plus 6. So either of 4 equals 0, or x equals 0, or x plus 6 equals 0. In that case, well, I mean, we've really now got three possibilities. 4 is equal to 0, well, that never happens, so we can throw that one out. But x equals 0, okay, we're pretty much done with that one, because I'm asking you to solve it. When I say solve it, tell me x equals. Here's x equals, so we're done there. X plus 6 equals 0. Well, that's a one-step equation by subtracting 6 from each side. And we get x equals negative 6, and that should be a solution. So now we can go back and take these, I guess, solutions, x equals 0, x equals negative 6, put them back in here and say, does it make sense? Does it make sense in the original equation? X equals 0. 4 times 0 squared is 0, plus 24 times 0 is 0. 0 equals 0, well, that works out. How about x equals negative 6? Negative 6 squared is 36 times 4, 120, 144, 144 plus 24 times negative 6 is 140, negative 144. And I'm plugging in negative 6 in here. Equals 0. 144 minus 144 is 0. 0 equals 0. Well, sure enough. So that one works. It checked out in the original. So x equals negative 6 and x equals 0 is our solution set. And you could say that our solution set is 0, comma, negative 6 if we're looking for solution sets. All right. Let's see. Pause the video and work on this one. Remember, this is kind of similar to this one up here. We cannot solve right now using the zero product rule by saying, 5s squared equals 45, so s squared equals 9. We can't do that, not yet. So let's take a look at this using the zero product rule. So pause it and use the zero product rule to solve this. All right, in order to use the zero product rule, we have to put everything on one side, put 0 on the other side, and say, well, in order to do that, we've got to subtract 6. Sorry, I'm looking at the previous screen here. We've got to subtract 45 because we're going to move the 45 to the one side, to the left side, to make the right side equal to 0. So we're going to subtract 45. Wow, all right. I'm catching my own mistakes at least. All right, so 5s squared minus 45 equals 0. And now that we've got everything in a quadratic on the left side equals 0 on the right side, we're okay. Now keep in mind, you could have put 0 on the left side as well. It doesn't really matter that 0 is on the left side. It would change the signs on the right side in this particular case. But in this case, it's easier to put the everything on the left side, 0 on the right side. So as long as everything's on one side, 0 is on the other, we're okay. So now let's start solving. How do we solve? We got to factor. Let's factor out a 5 times s squared minus 9 equals 0. Either we've got then 5 equal to 0, which doesn't happen ever, or s squared minus 9 equals 0. And how do we factor s squared minus 9? We could have just actually factored even s squared minus 9 even further. So even if we didn't factor it up here, we've got to factor it down here. What's s squared minus 9? Well, you know what? We're using our factor rules from a previous section. I think it was a previous section, 6.6. We knew that s squared minus 9 is a difference of squares. This is a perfect square. S squared is a perfect square because 2 is divisible by 2. 9 is a perfect square separated by subtraction. So this goes into, or factors into, s minus 3, s plus 3 equals 0. And we could say that's a 0. Then we could say that either s minus 3 equals 0 or s plus 3 equals 0. And how do we solve that? This would be s equals 3. We'd have to add 3 to each side. Over here, we'd have to subtract 3 from each side. We get s equals negative 3. And that is a negative sign right there. And now we can take these solutions of s equals 3, s equals negative 3, and plug them in. If s is 3, s squared is 9. 9 times 5 is 45, so that one checks out. If s equals negative 3 squared is 9. Remember, the squared applies only to the s. So negative 3 squared is 9. 9 times 5 is 45. That one checks out as well. So our solutions check out. All right, let's go to the next one and say, let's see. Let's pause the video and work on these two. And we'll come back and talk about them.